Hello guys, this is Leetcode 317, shortest distance from all buildings. So we've been given a grid where we have three possible numbers. Where we have 0, which marks an empty land where we can easily pass through. We have 1, which marks a building that we cannot pass through, right? It's a building, and also 2, which marks an obstacle that we also cannot pass through. So the only ones we can pass through, as previously stated, is for the ones with zeros, and we want to build a house on an empty land, right? So we want it to be on empty land that reaches all buildings in the shortest travel distance. So you can move up, down, right, left and right, normal, in the normal directions you can move. You know, most of these great problems, and we want to return the shortest travel distance for such a house, right? So basically, we are going to look for an empty space where we can reach all the houses, right? If it's not possible to build such a house according to the rules above, right, then we return -1. Um, the total travel distance is the sum of the distances between houses and the meeting point, and it shows how we get the distance, right, which is the Manhattan distance. So basically, is the difference between the coordinates, right? So difference between the x and y coordinates and the yeah, difference between the x and y coordinates, and that difference being an absolute difference. Okay, cool. So how are we going to solve this problem? Well, basically, one thing we can do is go through the grid and then get the buildings, right? Now, initially, we get the buildings, and then from the buildings, we traverse, right? So for my buildings, I'll be looking, we can turn the question around and say that, like, for my buildings, you're going to look for the empty spaces we can reach, right? So, what are the empty spaces I can reach from my building till I hit like an obstacle or another building? Right. So that's what I'll be interested in. So basically, we have basically, like, let's say I reach these obstacle first. I'll say, okay, I have reached this once, right? Or I've reached it a certain number of times, and now I've reached it. I mark it. So I mark not only the reached, right, but I mark also the distance, right? Like how many moves they take me from here, right? Which is, like, let's say a building to this point, basically. So basically, you have two different grades, where one grade is going to keep for each index or each zeroth node. Basically, we want to keep the minimum number of steps it took us to take to get here. So, like, maybe move from 1 to this point, and the minimum is 1, right? As opposed to moving from here, which is maybe the minimum from this one will be what, 1, 2, 3, right? So then this will be story 1. So it keeps the minimum distance so far, and then we're going to check from here how many buildings were we able to reach, basically, right? So basically, if we're able to come from here towards here, we increase this one's reach by what, initially I'll have it 1, and then I'll make it 2, and then if we are able to reach from here again, right, then we'll make it 3. So that's what happens in the question, right? So the you're given 3 buildings at 0004 and 42, and an obstacle at 02. So the point 12, right, and I believe it is this one, right? This is ideal because it will have a minimum a minimum number of steps basically to get to, right? Right. So that's how the question should be solved. And without further ado, let's get our variables, right? So the first variable we want is what, the grid's length, right? And we use this later to build new matrices, right? So the length of the rows and the columns, and then basically I want to keep the distances, and I'll call it a distance array or distances, and then takes shape M and N. And not only that, I want to also have what, one keeping the reach, which is what the basically going to keep, like, how many buildings did we reach from a given, like, position, or a given sorry, node with a 0 value, basically, right? So once that is done, we also want to keep what, as I was saying initially, we want to have what, the buildings that we'll be using. So the first one I want to call it buildings, right? It's going to be a new array list. Sorry. And then we go through our grid for let me declare variables I and also j, right? Sorry, I is less than m. Excuse me, and this one is okay, cool. Now, if it's a building, well, how we know it's a building? Basically, if the grade value is what equal to basically if the value of that box is equal to what 1, then we know it's a building. So if so, we now add to our buildings a new building, right? So add a new int list which has ing, right? The coordinates of the building. That's what we need. From that point on, what we want to do now is do the processing, right? So in our processing, we'll go through all the buildings, right? So I'll keep a variable called k, right? And k is less than the building size. Now, for each building, we'll do a BFS basically, right? So our BFS, what is it going to take? Our BFS is going to take the grade. It's going to take also our distances. So I want to be changing distances and reached, right? At each juncture. And not only that will it take that, but we also want to get like the actual building, right? So say buildings dot get what k, right? And also I'll pass in the current index k. Now the current index k is gonna be like the number of nodes we've reached so far, right? Like if you are going through the grade and we have a node that has been reached, sorry, that hasn't yet been reached, right? At all, but maybe on the fourth process or the fifth processing of this, it means maybe we are not able to get to that node, at all. Maybe there are maybe obstacles around it, like tools or something like that. So then I know not to process it for that node, right? So basically, I just have this key so that we check if like the reach there is it's going to be one less than the number of reach that we are looking at, right? So like let's say I process for the first building and I go on to the next one, so then the key will be 1, right? At that point, if I check my reached and the reached, for example, of a 0th node, maybe it's blocked by 2s, and I check and it has a reach of 0, or like it's not equal to k, right? Then I'll not deal with it basically. So I just want to keep the k also in our BFS. So after doing our BFS, right? What we'll do is, now that we have our distances array, right? We want to keep what something called uh, max value, right? Like we'll set our minimum to our max value, and then we'll go through basically, right? We'll go through the all the grades, right? Or every element in the grades, right? Um, in the grades that we created, or the matrices that we created, which is distances and reach, right? So when we go through them, what we're going to check is which one is our main distance, right? And basically, we want a point where it's not only 0 in a grade, right? But the reach is equal to the building size, right? Like the number of buildings we have, and also that is our minimum so far. If it, or that is our minimum. So what we want to check is if reach of ij is equal to 3. Sorry, it's not equal to 3, but it's equal to buildings, the size, and the grade ij, right, is equal to 0. Now, if it is, right, then fine. We want to update our min accordingly. If it's less than sorry, distances ij, basically, right? So that's it, and then we'll return uh, main, but main might be integer or max, right? So if it is integer or max, right, that's the question is demanding. Like that means there was no path possible. So what we want to do is return -1 instead, right? So if it's equal to -1, right, return -1. Sorry, if it's equal to, if the main is equal to infinity, right, return -1, else return the main, basically. Right, cool. So we have like most of the shell function, right? So now this is the main function, which is what our BFS, and our BFS is going to be a void method, right? And it's going to take what the grade. We need grade, we need distances, right? We need whether we've reached, and then the building we are dealing with, right? Building, and then basically key, right? So that we can check if I reach so on and so forth. Basically, cool. What is all this now? Cool. I just Okay, cool now. Okay, so basically with our BFS, we're gonna use what, a queue, right? Like normal BFS basically, we're gonna use a queue. Excuse me. So a queue of interlist, called a queue, is just a new linked list, right? And then also we want basically distances, right? So I'll call a variable um distance, which is what, one. Initially, I'll set it to one. I can even set it to zero and then change it in a while loop. It doesn't really matter. But basically, like this distance is the number of moves we've made, right? So basically, we are at a sorry, we are at a node, right? Like let's say a building, and then we are going to traverse and look for the next elements with, or the the next purchase elements with what zeros in them, right? Now every moment we make, we have to increase our dist, right? And then we update our distances array based on that, right? Like, right. So, um, that said, what do you do now? What we also want to do now is to add to our priority queue the first element, right? So we add a building to our, not a priority queue, but just a normal queue. Okay, so and then we'll ask now the while queue is not empty. Sorry, or the queue is not empty, right? What we want to do is keep the size of the queue. Sorry. And then for that number of elements, right, for size, then we will, pull and process, and then do process for further processing as it demands, basically. So basically, here then the distance, this, I want to increase it right now. This becomes one for every movement. And now I'm gonna have a simple while loop. While size is greater than zero, right? Then we keep pulling. So we'll say that whatever we are pulling first is the we're going to call it current, right? So q dot pull, right? Q dot pull, and after pulling, right, what we want to do then is to update the distances array with the preferred distance, right? So not only just that, but I also want to change what's the reach also in due time. But mind you, we have different directions, and I think that is something I did not actually um, define actually. So I have to add that to my BFS, right? Because directions, and I haven't defined that yet. Simply we can define it outside the whole thing. But directions will help us move. So because basically, if we are here, right, or we are at a certain building, we want to be able to move up, down, left or right, right, and then update for our BFS as we continue from there. Uh, so what I want to do is just declare our directions here, right? So it's sorry, it's of the four directions basically, right? So this is, sorry, left, right, and I think this is up and this is down. Okay, cool. So now we have our directions, right? We can use that in our BFS. So we are pulling for the current, and um, what I want to do now is to check for basically all the possible directions, right, we could have, and then move in those directions. And when we move in those directions, from then on, then we update the reached and the distances, right? So we start initially with what, a building, right? We move from the building, want to be passing through the elements with zero as the grade values, and then do the updates for that. So I'll have for int, and I'll call it dir in directions, right? We want to loop through directions, I want to create new variable. So direct sorry, x, my new x will be what? My current.I plus the first element, right? In wherever we get in our direction, right? This is the x component and this is the y component and so on and so forth. So that's what we'll be adding here, right? And then for the y will be what? Excuse me, to be dir1, right? Plus current. Actually, this is current one, right? Because it's a grade. I didn't make a class like edge or something like that. Okay, cool. Current 0 plus dir 0 and dir 1 plus current 1 is going to give you what? Your y. Right, so we want to check if it is in bounds, and not just in bounds, but also having the right number of reached, right? Like right number of nodes that have previously reached it, right? It should be equal to our key at each and every instance. Or we also want to check if it's the grade element is even 0 in the first place. So we want to check if our x is less than 0, right? Or our y is less than 0. Sorry, not 90, 0. Or if x is greater than or equal to what's grade dot length, or come on, y is equal to or greater than the, or I want to check if what's grade xy is not equal to 0, or what reached of sorry, reached a bit, okay, reach of xy if it's also not equal to k, right? If it's not, then we want to continue, right? We do not want to do the further processing. Else, what we want to do is now update not only our distances array, but our reached, right, for xy, and increase. So we increase. The distances we add what our dist, right? Because basically the Manhattan distance. So every move we make, right, we add it to our distance. Say, hey, if you move a certain number of times to get to this building from this node, and I moved a certain number of times from here to get to this node, and so on and so forth, right? So distance is xy plus dist, right? And then also you want to increase what's the reached, right? Sorry, it's not reached, it's reached. Y, want to increase it by 1, and not only that, we want to add a new element to our priority queue, right? So we have a new, and basically just the xy being added to our queue. Sorry, it's not priority queue, as I said. A queue, we add to our queue for further processing, right? And further processing. Yeah, I think this should be good. We have more of the core function written here. Let me run this down. Oh man, the new interface is kind of weird, bro. Not gonna lie, I like the previous one. Look at what's happening. Oh my days. Uh, I just want to remove this expand panel, guys. But yeah, we passed the first 3 test cases, right? Then let me submit. Right, and it's 84%. I think there are faster algorithms, and I've seen someone, combine distances and reached very nice. Like he had like a 3D matrix. But I think doing it this way is a bit more clear, right? We have distances, we have reach, and want to keep what distances, the number of moves it takes us from a certain building to get to wherever we are, right? We keep increasing the distances for all the buildings, and also want to check if we are able to reach all the buildings, right? So for every building that reaches a certain zero node with a zero value, right, we increase our reach. Then we process for the buildings, and do a BFS for each building. So the question is going to be, what is the runtime like in the worst case? Well, the worst case should be m times n all squared, right? Because basically M times N is what? M is the number of elements in our rows and columns, basically, right? So basically, in our grade, we're having N times N elements, right? And we are going to process for each of them. In the worst case, like we're going to attach them again and again. So it's going to be M times N to the power, sorry, M times N to the all squared, basically, right? All to the power 2. Really have to, get a hold of this platform. But I hope you guys, enjoy the video or got values from it. I'll see you guys on the next one. Peace.